Hi, my name is Katrina Apostle, and I'm here to propose that the town of Grand Canyon transition from simple data storage to cloud infrastructure. Currently, the town of Grand Canyon is utilizing a simple data storage. To assess the efficiency of TOG's current security standards, a comprehensive risk analysis was conducted. This assessment revealed major vulnerabilities in the TOG cybersecurity. Out of 245 controls, only 95 were compliant with HIPAA regulations. The other 150 pose as potential vulnerabilities that need to be ranked by severity and prioritized accordingly. The assessment identified several high risk items, including the lack of 1. An electronic protected health information data mapping, 2. An established security and risk management program 3. A developed HIPAA policy, and 4. A security awareness training program. For these reasons, transitioning to a HIPAA compliant cloud infrastructure would be beneficial because it can address these deficiencies and modernize TOG's information technology system. A cloud infrastructure is a combination of hardware, virtualization, storage, and networking components that enables computing services using internet connection. It virtualizes physical data so that it may be accessible to users remotely and on demand. There are three main types of cloud infrastructure or architecture: public, private, and hybrid. A public cloud architecture involves third-party cloud vendors so that it may be accessible to numerous customers. A private cloud architecture may be developed and managed by either the organization's personal information technology team or external providers so that it may only be accessible to the organization. Lastly, a hybrid cloud architecture incorporates both public and private cloud infrastructures. It utilizes the private cloud for more sensitive information, whereas the public cloud is utilized for less sensitive information and other computing tasks. According to HIPAA, covered entities must implement administrative, technical, and physical safeguards to protect the confidentiality, integrity, and availability of protected health information. A cloud infrastructure can remain HIPAA compliant by implementing safeguards and adhering to the standards of HIPAA's privacy and security rule. Cloud infrastructures also offers features like continuous monitoring, automated patch management, and cloud detection and response to help with maintaining HIPAA compliance. Staying informed on new and current regulatory standards are also beneficial. There are many benefits to a cloud infrastructure. First, it provides scalability. Computing resources can be allocated as needed and adjusted to meet the organization's fluctuating demands. Second, it provides cost efficiency. Computing resources are managed by external data centers, so organizational operations may be scaled with minimal to no financial investment. Cloud infrastructures is a cost-efficient alternative because it eliminates additional costs that would otherwise be needed for on-site hardware and maintenance. Third, it provides improved interoperability. Cloud infrastructures utilize application programming interfaces to enable seamless data exchange and communicate between systems. Enhanced security is another benefit of a cloud infrastructure. Cloud vendors can provide robust security services that can improve cybersecurity measures, secure EPH, and maintain patient privacy. First, the cloud offers automated threat detection by utilizing artificial intelligence and machine learning to quickly identify and mitigate suspicious behaviors and patterns. Second, the cloud offers automatic patching management so that the system remains current on recent security updates, reduces risk of cybersecurity attacks, and removes the burden of manual patching tasks from the IT team. Third, the cloud offers encryption key management so that data at rest and in transit may be encrypted. In other words, data may be converted into an unreadable format that can only be decrypted by a key possessed by authorized users. Encryption key management oversees and protects the lifecycle of all encrypted keys and prevents unauthorized access to PHI. Cloud vendors are essential to healthcare operations because of their role in hosting electronic protected health information and managing information technology services. This dependence, however, poses potential risks that can negatively impact organizational operations and PHI security. For this reason, it is important to manage these risks appropriately and integrate mitigation strategies. The first risk involves vendor downtime. Downtime and outages can disrupt organizational operations, delay access to electronic health records, and jeopardize patient care coordination. To mitigate this risk, organizations must select a vendor with a 99.999% service level agreement for all services. A SLA indicates the agreed percentage in which the cloud infrastructure would be available for service. This means that choosing a vendor with a 99.999% availability percentage ensures that there is only 5.26 minutes of downtime annually. Although a 99.9% SLA also appears to be a high uptime level, 8.76 hours of downtime can result from this annually. So selecting 5 nines or 99.999% SLA is ideal. Another mitigation strategy involves enabling geo-redundancy and automatic failover. Geo-redundancy is a process of replicating IT infrastructure so that it may be backed up into various geographic locations. This enables automatic failover. It is the concept in which another location takes over operational functions in the event the primary location experiences downtime or an outage. The second risk involves data breaches. With the increase in cybersecurity attacks, cloud vendors have a potential for experiencing a breach, thus leading to compromised patient information, HIPAA violations, reputational damage, and fines. To mitigate this risk, a business associate agreement between the organization and the cloud vendor must be obtained prior to collaboration. This ensures that the cloud vendor or business associate is held accountable for adhering to HIPAA regulations and safeguarding PHI. In fact, the HIPAA privacy rule mandates that a BAA be established prior to disclosing PHI. BAAs outline what circumstances permit the disclosure of PHI, data breach notification procedures, safeguards, and termination clause. Another mitigation strategy involves integrating safeguards to protect PHI as stated in the BAA. Regular risk assessments, encryption, and data center access control are a few examples of administrative, technical, and physical safeguards that can be utilized. The third risk involves vendor lock-in. This is a concept in which an organization becomes reliant on one vendor for services, thus making it difficult to transition to another vendor. This is problematic because the organization can experience significant operational disruptions if the vendor goes out of business. It will also be a costly situation because vendors can exploit the organization by increasing prices. To mitigate this risk, select a hybrid or multi-cloud infrastructure to diversify vendors and prevent over-reliance on a single vendor. Adapting an exit plan with open standards will also be beneficial as it outlines how an organization will transition from one cloud vendor to another, while enabling data interoperability and portability. To ensure a secure and seamless transition, TOG must first analyze organizational needs and develop a thorough data migration plan. In TOG's case, the comprehensive risk analysis identified high-risk items involving the lack of 1. EPH data mapping, 2. Established security and risk management program, 3. Developed HIPAA policy, and 4. Security awareness training program. Therefore, TOG's objective in transitioning to a cloud vendor is to mitigate these risks. TOG must select a cloud vendor that offers a EPHI data mapping, continuous risk detection and prioritization, cloud security posture management tools, automation tools, data encryption, access tools, etc. These are just a few cloud features that will aid in mitigating the identified risks. TOG must then select the best cloud migration strategy for the organization. There are 6 migration strategies: rehosting, retiring, retaining, replatforming, re-architecting, and refactoring. Rehosting involves shifting data and applications to the cloud with minimal to no modification. Retiring involves withdrawing outdated data and applications. Retaining involves keeping some data and applications on site while moving others to the cloud. And replatforming involves small changes to the application or infrastructure to incorporate cloud-based features. Re-architecting involves creating new cloud-based applications to replace older ones. Lastly, refactoring involves creating new cloud-based applications and modifying current applications to incorporate cloud features. Once TOG chooses a cloud vendor and migration strategy, a migration plan should be developed. First, the plan should outline the time frame, resources, and roles for each stakeholder in each stage of the migration process. Second, the data and applications that will migrate to the cloud should be identified while considering the chosen migration strategy. Third, a data governance model should be established by developing policies for managing cloud features and maintaining HIPAA compliance. Fourth, methods for training staff on the cloud infrastructure should be incorporated. This can include interactive classes, super users, and a 24-hour help desk. Fifth, end users' data access needs must also be met by integrating role-based access controls, user-centric interfaces, and training support. Role-based access controls ensures that personnel can only access PHI if it is pertinent to their position. User-centric interfaces ensures that interfaces are intuitive and easy for users to use and comprehend. Ensuring that adequate support is available to staff is essential during the transition period because there will be some resistance to change. Staff should feel supported by providing open communication and resources such as mentioned previously. 6. Contingency plans and risk mitigation should also be incorporated in the plan to prevent potential problems. Once the migration plan is complete, TOG will then implement the migration through stages so that a seamless transition can be promoted. Continuous monitoring and analytics will then be used to assess the efficiency of the system. End users can also contribute their feedback at this time. Weak areas can then be optimized by reallocating resources, improving security measures, etc. The success of the cloud migration should then be reviewed to assess if it meets the organization's objectives. As mentioned earlier, cloud infrastructures are a better alternative to traditional data storage because of its scalability, cost efficiency, interoperability, and security. Data can also be better managed through cloud infrastructures. Cloud-based health information technology tools gives a centralized platform for data management so that information can be accessed from any location with internet access. Data can then be delivered faster with more accuracy. This facilitates seamless data sharing, which then contributes to informed decision-making, continuity of care, and improved patient outcomes. Cloud-based HIT tools also strengthens the security of ePHI by providing robust security measures such as encryption, multi-factor authentication, regular data backups, etc. These measures help protect ePHI and maintain regulatory compliance to standards like HIPAA and the HITECH Act. Lastly, cloud-based HIT tools offer advanced analytics and artificial intelligence features so that larger quantities of data can be analyzed. This helps improve patient outcomes by developing early disease detection, remote monitoring, personalized treatment plans, etc. Large language models are artificial intelligence systems that processes large amounts of data to understand and generate human language. LLM can be leveraged to improve TOG's data categorization and response efforts. To develop their own LLM, TOG must first identify the objective of implementing an LLM. This can vary from streamlining workflows, automating routine tasks, etc. A large and relevant dataset must then be used to train and pre-process the selected LLM architecture so that quality control is ensured. The LLM can then be deployed into the cloud infrastructure. However, robust monitoring systems must be integrated to detect and address potential risks to the LLM. Alternatively, small language models can also be utilized for targeted tasks. A comparative analysis regarding the pros and cons of cloud computing should be incorporated in the data migration plan. This will allow TOG to weigh the strengths against the weaknesses and determine whether integrating the cloud infrastructure will be for the betterment of the organization. To summarize, the advantages of a cloud infrastructure include scalability, cost efficiency, increased interoperability, and enhanced security. However, limitations may include organizational dependence on the cloud vendor and vulnerability to internet outages. Dependence on the cloud vendor can predispose the organization to significant operational disruptions if the vendor goes out of business. To counter this, failover planning should be used. Vulnerability to internet outages can also disrupt operational functions and delay patient care. To counter this, a vendor with high service level agreement should be utilized. Based on these findings, TOG can then make an informed decision.